Have you ever wondered how a burst of light from the sun can turn our technological world upside down? Let's dive into the phenomenon of a solar storm. At its core, a solar storm begins with intense activity on the sun's surface, including solar flares and coronal mass ejections, or CMEs. These flares and ejections are spectacular eruptions that release vast amounts of energy and particles. As these particles are hurled into space, they carry with them the force of 1,000 nuclear bombs propelling through the cosmos at incredible speeds. Now this massive burst of solar energy begins its journey through space, heading straight for Earth. As the solar storm races across the 93 million miles separating us from the sun, what happens next? Imagine a swarm of charged particles hurled from the sun at speeds up to millions of miles per hour. This is not just a simple gust of solar wind. It's a full-blown storm, carrying with it the energy of 1,000 nuclear bombs. As these particles travel through space, their journey is closely monitored by a network of satellites and ground-based observatories. These guardians of the galaxy, equipped with cutting-edge technology, track the storm's every move, predicting its path and potential impact on our planet. While this cosmic ballet unfolds, Earth braces for impact. The storm arrives with a flash of auroras, but the effects go beyond just a light show. When a solar storm travels the vast expanse of space and reaches Earth, it interacts powerfully with our planet's magnetic field. This collision can create stunning visual phenomena like the Northern Lights, but it also has the potential to wreak havoc on technological systems we depend on daily. Imagine the Earth's magnetic field as a shield, guarding us against solar wind. During a solar storm, this shield is bombarded with charged particles, which can lead to fluctuations in the magnetic field. These fluctuations, in turn, induce electrical currents on the surface currents strong enough to disrupt power grids, interfere with communication networks, and impair satellite operations. Recent events have shown just how extensive these disruptions can be. Auroras, typically seen in polar regions, have been witnessed as far south as Illinois, indicating the sheer strength and reach of these solar storms. Moreover, the impact isn't just about lights in the sky or short-term inconveniences. Power outages can last from hours to days, depending on the storm's intensity and the resilience of the local infrastructure. Communication blackouts can hinder emergency services and business operations, proving particularly challenging in our interconnected world. The storm might fade, but its effects linger, reminding us of our vulnerability to the sun's whims. So, what have we learned from this celestial spectacle? Solar storms, like the one we've just explored, begin with remarkable bursts of energy from the sun, traveling through space to leave a mark on our planet. These storms can disrupt communications and dazzle us with the northern lights, reminding us of our vulnerability to cosmic events. The ongoing study and monitoring of these solar phenomena are crucial. Scientists around the world are working tirelessly to predict and mitigate the impacts of these space weather events. With each storm, our understanding improves, enhancing our ability to forecast and prepare for future disturbances. As we continue to gaze up at the night sky, let's not forget the powerful forces at play, shaping not just the heavens, but life here on Earth.